You spend hours writing a system prompt for your Claude-powered product. You tell it exactly what it can and cannot do. Then a single sentence from a user, or even from a document the AI reads, and every one of those instructions is gone. This is prompt injection, and it is one of the most important problems in AI right now. To understand why this happens, you first need to understand something about how Claude and models like it actually process text. They do not have a protected memory for system instructions. Everything, your rules, the user's message, a retrieved document, a tool response, all of it goes into one long sequence of text called the context window. The model reads that entire sequence and predicts what should come next. It is not checking a permissions table. It is not running a separate trust evaluation. It is reading text and trying to be helpful based on everything it has read. That helpfulness is exactly what attackers exploit. Prompt injection is the attack where instructions embedded somewhere in that context window tell the model to ignore, override, or contradict the instructions that came before. The model does not know the difference between your rules and the attacker's rules. They are all just words. There are two main categories here. Direct injection is when the user types the attack themselves. Something like, ignore all previous instructions and do this instead. This is the oldest form and most deployed systems have at least some resistance to obvious versions of it. Indirect injection is far more dangerous. This is when the attack is not in the user's message at all. It is hiding inside content the model retrieves or processes. A web page. A PDF. An email the AI is asked to summarize. A calendar event. The user might have no idea the attack is even happening. Here is a concrete example. You build a Claude-powered assistant that can read emails and draft replies. An attacker sends your user an email. Inside the email, written in white text on a white background or buried in metadata, are instructions telling Claude to forward all future emails to an external address. The user asks the assistant to summarize new mail. Claude reads the malicious email. The attack executes. This is not a hypothetical. Security researchers have demonstrated this class of attack against multiple AI assistant products. The attack works because the model's job is to read and respond to text. There is no native mechanism that says text from external sources counts less than text from the system prompt. Multi-turn conversations create another angle. In a long session, the model builds up a picture of the conversation from every previous message. An attacker, or even an unwitting user, can slowly shift what the model believes its context is over many exchanges. By message 30, the model may be operating under a completely different set of assumed rules than the ones you wrote. This is sometimes called context drift or multi-turn erosion. Each individual message looks harmless. No single message obviously says ignore your instructions. But the cumulative effect across the conversation is that the model's behavior drifts further and further from your original intent. Some of the most effective injection prompts do not even look like attacks. They use role-play framing. They claim to be system-level messages. They tell the model it is in a testing environment where normal rules are suspended. They claim the original instructions have been updated. The model has no reliable way to verify any of these claims. Anthropic has acknowledged this problem class publicly. Their research on agentic AI and their guidance for building with Claude both note that prompt injection is an unsolved challenge, particularly in agentic settings where the model takes real-world actions like browsing, writing code, or calling APIs. The stakes go up dramatically when the model can do things, not just say things. So what can you actually do? The first strategy is input sanitization and content separation. Some developers try to wrap untrusted content in XML tags or structured delimiters to signal to the model that this text is data, not instructions. This helps at the margins but is not a reliable defense on its own because the model still reads it all. A second approach is output monitoring. Instead of trying to prevent the injection at input, you check what the model is about to do before it does it. If a model deployed as a customer service bot suddenly tries to send an email to an unknown address, a rule-based monitor can catch that action before it executes. This works well for agentic systems with limited action spaces. A third strategy is privilege separation. You design your system so the model that reads untrusted documents is not the same model, or does not have the same permissions, as the model that takes actions. The reader and the actor are separated. An injection in the reader cannot directly trigger an action because it has to pass through a separate verification layer. None of these fully solve the problem. Input sanitization is bypassable. Output monitoring requires you to predict every dangerous action in advance. Privilege separation adds architectural complexity and still has edge cases. The honest answer from the research community right now is that prompt injection is an open problem with no complete solution. That does not mean you should avoid building with these models. It means you should build with an honest threat model. Understand what your system can be made to do. Limit the actions available to the model. Treat every piece of external content as untrusted input. Log everything. Audit regularly. The analogy that makes this click for most people is SQL injection from the early web era. For years developers passed user input directly into database queries and attackers used that to read or destroy data. The fix was not to stop using databases. The fix was parameterized queries, input validation, and a culture shift toward treating user input as untrusted by default. AI needs the same culture shift. If you are building a product with Claude today, the single most important thing you can take from this video is this: the system prompt is not a security boundary. It is a strong default. Attackers and edge cases can move the model away from it. Build your safety guarantees at the application layer, not inside the prompt. If you are a user rather than a builder, knowing this helps you understand strange AI behavior you might have already seen. If a chatbot suddenly starts acting oddly after you paste in content from an external source, that external content may have contained instructions the model followed without telling you. This is a fast-moving area. Anthropic, OpenAI, Google DeepMind, and independent researchers are all working on better architectures and training approaches that could reduce this vulnerability at the model level. We will be covering those developments as they happen on this channel. If this video helped you understand prompt injection and why it matters, hit the like button. It takes 2 seconds and it genuinely helps this channel reach more people who are trying to understand AI systems honestly. Subscribe so you do not miss the next video, which covers how attackers use Claude and other models to generate convincing phishing content at scale and what detection looks like.